Good day to all. Myself, Tinetra, presenting the working principles of DC motor and the physics phenomena associated with it that I would visualize using a simple working model. The materials required are fidget spinner, magnets, hot glue gun, copper wire, cylindrical cup, woolen thread, magnetic switch, wooden pieces, wires, power extension, and an electric source. And by the way, all the materials used in the activity are purely household products, and this model is totally homemade. So, let's get started with the procedure. First, let's take the fidget spinner and the three magnets. Next, we have to check the polarity of magnets using the concept of magnetic attraction and repulsion and mark all the three faces having like poles using a marker. Then, using the hot glue gun, we will fix the magnets permanently to the spinner. Make sure that the magnets are glued properly to the spinner to avoid further altercations. Next, take a copper wire. These copper wires are already insulated with varnish, so there would be no problem of short circuits. I have used a cylindrical measuring cup for a rigid support to wind the copper wire around it. I have made about 500 turns of wire. Make sure that the two ends of the wire are left free. Next, take a woolen thread to tie the coils together after removing it from the cylindrical cup to ensure that it's rigid and in shape. Now the coil is perfectly in shape and ready to use. Here comes the most interesting part. Take a wooden slab and fix the fidget spinner with magnets to it. I have used the fidget spinner with magnets as a rotor that would act as a permanent magnet. I am making sure that the rotor is moving freely and is balanced and rigid. We will keep this apparatus aside and start with the wiring works. I have taken a charger of my old toy instead of a 9-volt battery as the electric source. The electric source has two terminals. One is the positive terminal and the other is the negative terminal. Now, using a multimeter, I am checking the continuity between the two terminals of the wire. Now, I will attach the two terminals of the wire with the two ends of the coil that we made earlier using an insulation tape. I have turned the switch on for the current to flow through the coil. As our physics ma'am said, when electric current flows through the coil gets magnetized. This can be seen when the metal piece is getting attracted to the current carrying coil or electromagnet. In this activity, I will use this current carrying coil as the electromagnet. As you can see, the poles of the magnets are repelled by the poles of the electromagnet. Next, we will use a magnetic switch which performs the function of commutator in DC motor. The commutator helps to switch the polarity of magnets, which is the function also performed by magnetic switch. Now, I will disconnect one end of the coil from the circuit and connect it in series with the magnetic switch. Secure it using insulation tape. Next, I will connect the other end of the wire with the magnetic switch by soldering it using a soldering iron. Almost all the work is over. I would like to fix a wooden stand where I would attach the magnetic switch to keep the magnetic switch at a right and static position such that the rotor is able to rotate freely as well as the magnetic switch is positioned properly. As you can see, the rotor now moves very freely. Now, I would attach the magnetic switch to the wooden piece using hot glue gun. Allow it to stick for about a minute. Next, I am using another wooden piece to fix the coil at a fixed position such that it rightly repels the rotor or permanent magnet. We will tie the coil to the wooden piece using a woolen thread. Now, let's fix the wooden piece with coil to the wooden slab using hot glue gun. Now, let's check whether the connections are tight and secure. Now, our concept of DC motor is ready. Hopefully, it works. Let's see. Oh, it started to work. It's working pretty good. The concept behind its working is that the electromagnet or magnetized coil is repelling the first magnet, causing it to move away. At the same time, due to the concept of centrifugal force, the first magnet moves in a curved path directed towards the center of rotation. This causes the second magnet to come in the place of the first one, and once again the coil repels it. This gives the constant motion for the rotor, which rotates continuously with its speed increasing constantly. Through this project, I would like to conclude the magnetic effects of electric current and the Faraday's law of induction. Thank you.